So you've finished up hopefully the first page of today's assignment. As you work down through there's on the back side, you'll notice that there's some options to do a different method. It'll say this on the back. If you want to use the normal factor label, the factor label just means whatever your unit was starting here goes in the bottom of the first fraction, and you just have to have some equal amount in this fraction because you're literally multiplying by 1, the same amount at the top as on the bottom to come up with the answer. So you take 4 times 3, you take the tops times each other. But you can also use the this factored label method here. And so if you're starting out with 4 moles of HNO3 in this particular case, you can just say, well, I'm out here at moles of the whole compound, right in there, okay? And if I have 4 moles of the whole compound, then what do I need to do to get to some part of the compound, which is, says multiplied by the subscript. So you're going from the whole to the part in the moles area. You can multiply by the subscript, so that's going to be multiplied by 3 to get 12 moles of oxygen. Now I'm going to do a couple examples that are also on the notes here, so let me switch back to those. The Hart method really is, it's the same thing that's going on here. If you were looking, for instance, just at this one, when I went from moles to molecules, it said, hey, I got 3.74 moles. How many molecules do you have? What are you effectively doing? Basically, you're taking 3.74 and it's on the top of the fraction. You're multiplying by the gram atomic mass. So anytime you're going from moles to numbers of particles, numbers of atoms, numbers of molecules, you're multiplying by the 6.02 times 10 to the 23rd there. And the same thing, if there's going to go from moles to how many grams there were, what are you effectively doing? Well, you're multiplying by the gram atomic mass. So these arrows are telling you what you can effectively do. And the reason I bring this up, we use this factor label all the time. We first saw it when we were doing some things in physics. We did a page on those. But now we're using chemistry. And if you are used to those and you like doing those, stick with those. That's okay. But if you like this, I'm kind of a shortcuts person. And so I do like to use this Hart method. Usually they say, why is it called the Hart method? Because at the center of this, there's, the mole is the heart of what we change in between grams, moles, particles. And if we had a longer course, I'd talk about how you change it to volumes and gas as well. So that's sort of the idea of why they call it the Hart method. It's in several textbooks that are out there. So let's take an example. These 2 examples that are from the worksheet and they're in the back side, and I've got them is the example there. So if I had 144 grams of calcium hydroxide, how could I do this with this Hart method? Well, I'll show you as a comparison, but first let's just use this Hart method so you get the hang of what it says. I'm starting here at 144 grams, okay? That we have 144 grams, and I need to get to hydrogen atoms, number of particles over there. So what am I going to do is I'm going to take 144 grams and I'm going to go against the arrow. If you're going against the arrow, you're going to do the opposite of what the arrow says. It says multiply by the gram atomic mass, which is 72 for this. Calcium's 40, that's 16 and 1, that's 17. There's 2 of those at 34, 17. Sorry, 34 plus 40 is 72. So if I'm going to go against this arrow, I'm going to take 144 and divide by 72. Now I've tried to give you a pretty even amount of numbers on some cases so that you get the hang of this. 144 divided by 72 is just 2 moles of calcium hydroxide. Now, I'm down here at moles, but I have the whole compound. Okay, so I'm going to hit this whole compound of calcium hydroxide, but it's asking for hydrogen atoms. So if I want to get to just part of the molecule, part of the CaOH2, I need to get over here and I have to multiply it by whatever the subscripts are. And remember, if there's a subscript inside and a subscript on the outside, you got to multiply both, by both of them. This one only has 1 on the outside. That means there's twice as many hydrogens for every calcium hydroxide you have. So I'm going to multiply that by 2. So 2 moles of calcium hydroxide times 2 gives me 4 moles of hydrogen atoms. Okay, I'm back here still at moles though, but I want to get to the number of moles of particles of hydrogen or actual atoms of hydrogen. So I'm going to go along this arrow and it says multiply by 6.02 times 10 to the 23rd. So I take 4 times 6, that's 24 times 10 to the 23rd. Now a lot of times I'll drop out the 0.02, and if you want to do that for the problems we do, totally great. Just take 6 times 10 to the 23rd. It'll make it easier, and in most cases that'll be fine. So that's how I've done this first one. Now, did I do anything really different? No, because if I would have started with this, notice I would have taken 144 grams the whole molecule. And just to get to here, I would have taken it times some fraction. For every 1 mole of calcium hydroxide, I have 72 grams of calcium hydroxide. And what do I end up effectively doing? Just dividing by the gram atomic mass, just like I was saying. When you go against these errors, you're going to divide, and that's because we set those conversion fractions. Whatever the unit was starting, grams of calcium hydroxide went on the bottom. Moles is what I wanted to change it to, is on the top. And so that helps me to say, oh, I'm just dividing by the gram atomic mass to get to those. And so I find that it's a little easier. Otherwise, you're going to have to still think this is a good diagram, even if you're going to set up the conversion fractions, because I had to get from grams over here to particles. So I had to change it to moles first, then I had to change it to, some part of the moles second. So that would have taken another conversion fraction, just like you have it here. Okay, so now I'm in moles of calcium hydroxide. I'd have to set this up for every 1 mole of the whole thing. I would have had to have 2 moles of H. Okay, and that effectively does the same thing as this calculation does, which is the whole to the part you multiply by the subscript. Okay, so I would have had to make several of these conversion fractions to work for me. Okay, and then that would give me 4, right? 144 divided by 72 is 2 times 2 is 4. And then the last one I would still have, I've got 4 moles of H. I would have had to come up here to particles, and so I would have still had to change this from moles of H into number of atoms of H. And of course, that's 6 times 10 to the 23rd atoms of H. So what would have happened is 144 divided by 72, which is 2. Then I'll take that times 2, because there's 2 H's for every CaOH2. And then that would have been 4. 4 times 6 times 10 to the 23rd is 24 times 10 to the 23rd. So you have to determine, this is a little bit more writing, but some students really get that down first, and then like to do that first method because they got it. In this case, I'm going to start this second one, and I've got them written small, so I'll do this fairly quickly. 3 times 10 to the 23rd waters. Okay, so I'm way out here, 3 times 10 to the 23rd waters, and it's asking how many grams of this substance are over here. So this one's not too bad. I'm just going to go from particles to moles to grams. So 3 times 10 to the 23rd, I'm going to move down towards moles. That means divide by 6.02. You're going to do the opposite of what the arrow says. So 3 divided by 6, that's just 0.5 moles of water. 0.5 moles of water. And then I need to get up here to grams of water. So that just tells me take it times the number of hydrogen and oxygen's weight. 2 for each hydrogen's 1, oxygen's 16. So that's 18 grams. So half times 18 is 9 grams of water. So if you like this method, this Hart method, I did include it on the back side of the sheet so you can refer to it on your worksheet. So please feel free to use that and finish down through all of these if you want. And when you get to 21, I'll leave a little video for that too.